All right, folks, you can see you're looking at 11.1 notes. This is what we did last Friday after you were done with your test retake or while others were doing their retake. I wanted you to watch that video. If you haven't done that yet, you got to go back and watch that. I want you to get some good notes. Make sure you're listening to the audio and everything, because what we're going to do is we're going to use those notes to understand 11.2. Okay, so I'll give you a quick little summary of what we were doing back here in 11.1, just in case you've forgotten. It's been a few days, right? So we were talking about polynomials, and polynomials get, special names. If there's one term, it's called a monomial. So this guy right here was a monomial. And then if it has two terms, it's called a binomial. So here we had 9x minus 2. I wrote x to the 0 because you could think about like we have an x to the first power, then we have an x to the 0 power. So the powers are decreasing if you have them written in standard form. This was just written initially as 9x minus 2. Okay, so it is two terms. They're separated by, a subtraction here. So here's a term over here. A term is factors multiplied together. So we had a 9 and an x. So we had term, like a term here and a term here. So that was two terms. That's why we called it a binomial. This one had three terms, 1, 2, 3 terms, and it was called a trinomial. Okay, so this guy back here was not a polynomial. So let's just get that out of the way. What is a polynomial and what is not a polynomial? When we looked over here, we did some homework problems in those notes. We said this was a polynomial. This was not, because you can't be dividing by exponent. This guy right here is another example of not. This is, let me put that down here. This is not a polynomial because the variable cannot be in the exponent. That's what makes this not a polynomial. Variable is in exponent. Okay, that cannot happen if you're going to have a polynomial. So back here, you might say, well, there isn't a variable at all. Why is this one a polynomial? Well, like I was saying, it's like an x to the 0 power. So anything to the 0 power is 1, so you don't see an x there. It's like 21 times 1. So this is a monomial, has a degree of 0. So the degree of the polynomial is the highest combined exponents if you have more than one variable. So like, let's look at this one down here. This one gets a degree of 4 because it had a 1 in the exponent for the n and has a 3 in the exponent for the q. So you add those together, the 1 and 3, and it makes a degree of 4. Boy, there's a lot really in section 1. There's a lot of vocabulary. Do you know what the degree is? Do you know what you could call them, like a monomial, binomial, a trinomial? Do you know what standard form is? So when it asks you to put it in standard form, it's just saying put the exponents in decreasing order. So this was the third, power. Here's the first power, and then we had a 0 power over here. So this one's in standard form. In section 2, there's not quite as much information really. All we're doing in section 2 is we're going to multiply. We're going to multiply by a monomial, and we're going to what they call distribute it through another polynomial. So that means that we need to take this b, and we're going to multiply it by this b squared. We got to take the b and we got to multiply it by the 12b over here. We got to take the b and distribute it all the way down to the 1 and multiply way the heck over there. Now let's just do the easiest thing first. B times 1 is just a b. And b times 12b, well, let's think about that. We could put down, it's also a minus 12b. So I'm going to put down minus 12 times b. That's that b right there. So that's what that means, minus 12 times b. But we're also multiplying by this b too. So I'm going to put times b. And then we got a plus over here. I was kind of ahead of myself. I definitely need to put that plus down. Okay, there's the plus sign. And then this 1 times that b gave me this b over here. All right, we're going to simplify this. Of course, nobody wants to write b times b, particularly if you have lots of them. Like if you had 5 b's all lined up to be multiplied together over here, we have an easy way to do that. So I'm going to take b times b squared right here. So I get, let's just put it like this, b squared times b. Okay, so I've distributed the b through the trinomial. This guy right here is a trinomial right here. Let me put down that little prefix. And then this guy over here is called a monomial. And so that's what we're doing. We're multiplying a monomial by a polynomial. It could be a trinomial. It could be more terms than 3. Anyways, let's get back to simplifying. So I got two b's multiplied together here, and I got one more b multiplied by that. So that's going to be b to the third power. You add exponents, like there's an invisible 1 up there. 2 plus 1 gives you the 3. Add exponents when you're multiplying the same bases, right? And then right over here, we got minus 12b squared, and then we'd have plus b on the end. So you can see the powers are decreasing as we go across. So this is in standard position. The power over here is an invisible 1. So we got 3, 2, then 1. And the leading coefficient, in case they ask us about that, the leading coefficient is a 1. 1 is the leading coefficient, okay? Woo! So some of this stuff, comes from section 1, like this stuff about leading coefficient and standard form, because I think if you don't put it like this into McGraw-Hill, it's going to count you wrong. And you don't want an invisible 1. You never put the invisible ones down because they're invisible, right? So let me erase that little 1 from here. And let's see. I hope I made that clear. Number 11 looks way more complicated. But really what it comes down to is it tells us the formula for a pyramid like this is 1/3 the area of the base times the height. And then it tells us the height is 10 right here. So I'm going to plug 10 right in for the height. So 10 is going to go right there. The base is given by this polynomial right over here. And I'm going to put it in a little different order so it looks kind of like what we were doing over here. So the volume comes out to be 1/3. And instead of putting the 10 at the end, I'm going to put it in the front. So I'm going to put 10 right there. And then we would have the base. So it's x squared minus 4x minus 12. Now, I'm thinking they want us to multiply this out. So 1/3 of 10 is not a whole number, right? 3 doesn't go into 10 evenly. So I'm going to write it like this. 10/3. I'm going to write it as 10 over 3. So let me come down here and show you why I'm doing that. So 1/3 times 10 over 1 is just 10 over 3. And the reason I'm doing that is because then I could write right out in front of the x squared. I could put 10/3 x squared, and then I'd have 4 times 10, which would be 40. So I'm going to get minus 40 thirds x. Then I'm going to get 12 times 10 all over 3. So that'd be minus 120 over 3. Okay, so I don't know if McGraw-Hill is going to take this because you can see 3 goes into 120. And maybe they want a mixed fraction. I don't know. So it could be 3 1/3 x squared. This would go into there, 13 times with the remainder of 1. So I think it's minus 13 1/3 x. And 3 goes into 120 evenly. So that'd be minus 40. Whew! You guys are doing some heavy-duty math. And I hope I'm making this clear. That option right there, that is perfectly fine. I think this is a totally fine way of writing it. But remember, we're dealing with a computer, so we're not sure which answer the computer would like. Okay, now part B, how do you do this? Well, you plug 12 wherever you see x. So we're going to have, and this would probably be a Desmos, situation here. So we're going to take 12 and we're going to square it. And then we're going to have minus 13 1/3 times 12. And then we'd have minus 40 because we're just plugging the 12 in for wherever we see x, right? So that's going to be the volume of our pyramid. And like I said, just jam it into Desmos. Good luck, everybody. I hope I'm making this clear. I really care about you. I know you can be successful with this.